Welcome to This Explainer. Today, we're unpacking a really fascinating, highly relevant piece of scholarly work by researchers Murillo, Edson, de Carvalho, Souza, and Li Wei Gong. We are looking at the absolute titans of today's tech world, Grok, Gemini, ChatGPT, and DeepSeek, and we're breaking down exactly how they stack up against each other.
Our focal point today is a rigorous study by these two researchers. Honestly, they've done a remarkable job synthesizing the capabilities, the underlying architectures, and the very distinct applications of these massive language models. It's so vital to acknowledge their contribution here because they've given us a really clear, objective lens to understand the tools that are literally reshaping our world as we speak.
So, here is our roadmap for today. First, an introduction to conversational AI. Next, comparing the four models. After that, algorithms and architecture differences. Then, applications by specific sectors, and we will wrap things up with ethical challenges and future.
All right, let's jump right into Section 1, Introduction to Conversational AI.
The essence of this tech is just fascinating. The authors state, quote, "These models are based on deep neural networks trained on massive datasets, enabling the understanding and generation of natural language in an increasingly sophisticated manner." Now, since you follow the space, you know that these tools aren't just spitting out programmed responses. They learn from vast oceans of text to actually mimic human conversation. They pick up on patterns, context, the subtle nuances, which is exactly why interacting with them feels so incredibly natural.
Moving right along to Section 2, Comparing the four models. When we map out this landscape, you immediately see some very distinct design choices. Take a look at this breakdown. You've got Grok, which is an X-based model, meaning it leans heavily on the social network X for its training. Gemini, on the flip side, is built from the ground up to be fully multimodal. Text, image, code, all seamless. Then there's ChatGPT, leveraging that massive GPT-4 architecture, focusing heavily on broad text and code generation. And finally, DeepSeek, which is highly specialized in search and structured knowledge retrieval. You can also see right here how their accuracy levels shift depending on these specialized training environments.
Let's drill down a little deeper on Grok for a second. Developed by XAI, the paper highlights a very specific operational choice here. The authors note, quote, "Its implementation prioritizes freedom of expression, allowing responses that may diverge from the most conservative content moderation guidelines." Because it integrates directly into the X platform, it's processing real-time live discussions. And that fundamentally shapes a highly dynamic behavior compared to the others. We're purely looking at the design intent here, right? It's a system built for real-time, unfiltered trend analysis.
And that creates a really sharp contrast when we look at ChatGPT and DeepSeek. As the researchers point out, ChatGPT is your broad generalist model. It's the jack of all trades, highly capable at almost everything, from drafting emails to coding software. DeepSeek, however, takes a laser-focused academic approach. It excels at verifiable information retrieval. If you need highly accurate, structured data recovery without all the creative flair, DeepSeek is engineered specifically for that task.
Which brings us to Section 3, Algorithms and Architecture Differences.
When we look under the hood at architectural efficiency and latency just being the time it takes for the AI to spit out a response, some clear trade-offs emerge. Notice how ChatGPT has high scalability but relatively low efficiency and higher latency, mostly due to its massive computational size. But conversely, look down at DeepSeek, very low latency and very high efficiency. So how exactly does it pull that off? Let's break down the techniques behind these numbers.
The crucial differentiator is how they learn and process data. ChatGPT relies on RLHF, which is reinforcement learning from human feedback. This means human trainers actively refine its responses to be helpful and conversational. Gemini uses a hybrid approach, mixing supervised learning with self-supervised context recovery. But DeepSeek's secret weapon for that high efficiency we just saw? It's a technique called pruning. Basically, as the paper notes, pruning strips away unnecessary computational weight from the deep neural network. It reduces the overall complexity, so the model runs blazingly fast without sacrificing any of its accuracy and data retrieval. Pretty brilliant, actually.
All right, let's look at the real world in Section 4, Applications by Specific Sectors.
The researchers make it abundantly clear here. There is absolutely no single best AI out there. The ideal solution depends entirely on your professional context and the specific demands of whatever task you're tackling.
Let's walk through their precise recommendations. For social networks, trend analysis, or open debates where real-time context is just essential, Grok is your ideal tool. If you need advanced support for data science, handling text, image, and code all at once, Gemini's multimodal nature is virtually unmatched right now.
ChatGPT is highly versatile, making it the absolute go-to for automating administrative workflows, customer service, and e-commerce. And finally, for academic research, legal support, or specialized technical consultancy where data accuracy is absolutely non-negotiable, DeepSeek is the fundamental requirement.
Now for the heavy stuff. Section 5, Ethical Challenges and Future.
As the paper outlines, with immense computational power comes some pretty solemn responsibility. The authors dedicate a lot of attention to the major barriers to safe implementation. The three massive pillars of concern they identify are algorithmic bias, hallucinations, and some severe data privacy and security risks. Let's look closely at what actually happens when these systems fail. The phenomenon of AI hallucinations is a huge focal point in this research. The authors define it clearly, stating it, quote, occurs when the model generates incorrect or unfounded information. This problem is particularly critical in applications that require accuracy, end quote. Think about this in the context of, say, healthcare diagnostics or drafting legal documents. An AI hallucinating a key fact in those environments isn't just a funny glitch. It has very real, potentially dangerous real-world consequences. And this brings us right to algorithmic bias. Because these models are trained on just massive volumes of internet data, they soak up the social, political, and cultural biases of humanity. The AI, by design, can easily reproduce and even amplify these biases, generating skewed or inappropriate responses. The researchers emphasize that there's a strict ethical imperative to mitigate this. We have to build systems that reduce bias without completely losing the diversity of human thought.
This leads us directly to the ultimate takeaway from Souza and Wiegang's research. They conclude, quote, the success of conversational AI in the future will depend on the balance between technological innovation and ethical guidelines. We can push for lower latency, better multimodality, faster pruning, all of it. But if we don't have robust frameworks in place for privacy, transparency, and fairness, the whole technology is going to falter.
I want to leave you with this profound thought to chew on. How will we, as a society, ensure that the rapid advancement of these incredibly powerful AI tools remains a force for ethical good? It's a question we absolutely must engage with as these models become deeply, permanently integrated into our daily lives. Thank you so much for joining this explainer, and a huge special thanks to authors Mario Edson de Carvalho Souza and Li Wei Gong for their vital research. See you next time.